All right. Good morning, everyone. Hope you're having a good Monday morning so far. On behalf of the staff of the Tennessee Transportation Assistance Program, I'd like to thank you for joining us this morning for our webinar titled Leveraging Big Data and Data Analytics and Signal Optimization, a case study with the Minnesota Department of Transportation. I'll be filling in today for Ayrton Coles, who has a teaching engagement this morning. My name is Matt Kate. I'm the TTAP Program Director. So again, thank you for joining us. As we get started, I want to go over a few things. A lot of you who are regular TTAP workshop and webinar participants probably already know the routine, but for those who might be new, we'll go through the basics here. So we check your attendance, of course, by your registration. We ask you to sign in by entering your first and last name in the chat box. That lets us make sure we're matched up. We have the right person paired with your Zoom user ID in case it's one that's not immediately clear who you might be. And beyond that, no need to sign out. At the end of the day, we'll be able to see using the analytics when you come and go. So see lots of you already signing in. During the webinars, of course, it's a little more difficult to have direct interaction. We're going to ask you to enter your questions in the chat box today. We will be saving questions up and we'll address those at one point kind of in the middle of the presentation today, and then we'll address any remaining questions at the end of the presentation. So a little bit different format maybe than you're used to, but please do enter those in the chat box and be sure to address your questions and comments to everyone in the meeting, so that myself, Justin, and others are able to see those. Your PDH certificates, so you'll be eligible for one professional development hour upon completion of today's webinar. Those certificates are going to go out to you within the next 2 weeks, probably sooner than that, but certainly within the next 2 weeks, you'll get those via email. And then finally, you should have had a link to download a PDF with the copy of the slides for today's presentation in your Zoom reminder emails. You got one a day ahead of and an hour ahead of the webinar. If you didn't see the link or for some reason you didn't receive the email, I will put the link to download those slides in the text box once we get started and once everyone has had an opportunity to sign in so it doesn't get lost in the clutter. So before we get started and before I hand things over to today's presenter, I want to read you a little bit about Justin's background. So today's instructor is Justin Effinger. He's a professional engineer and a professional traffic operations engineer. He's a seasoned traffic engineering leader with over 14 years of extensive experience in traffic signal and intelligent transportation systems operations. He specializes in advanced traffic signal operations, automated traffic signal performance measures, and integrating and enhancing various ITS technologies. The ATSPM program Justin created at Lake County, Illinois, won the 2019 ITE International Transportation Achievement Award for Operations, and his Ann Arundel Signal Optimization Project won the 2025 National Operations Center of Excellence TISMO Award for traffic signals. Before joining Meade and Hunt, Justin also worked for No Traffic, which I find to be a fascinating name for an organization, Lake County, Illinois, and the Wisconsin Department of Transportation. So with that, Justin, I'm going to turn things over to you to get us started.
Thank you, Matt. I will share my screen. Can you see the title one?
Yes, we see your title screen.
All right, perfect. All right, I'm going to be talking about a case study that I've been working on with the Minnesota Department of Transportation. It's going to go through a lot of material. Hopefully it'll prompt a lot of questions. And I have quite a lot of text on the slide so that I won't be especially reading through all of it, but I know the slides will get sent to everyone so you can kind of go back and see what I was talking about. So kind of just some background of traffic signal operations in itself. Something that we're used to is the time of day coordination. It's those fixed coordination plans, AM peak, mid peak, PM peak, sometimes off peak. Very predictable. Sometimes we'll do some modifications with special events, holidays, and things like that, but very predictable type of traffic signal operation. So we've been optimizing for that for a very long time. And then integrating some of the more historical advanced technologies, being traffic responsive, which takes those same coordination patterns, but allows the starting and ending points to be different based on the volumes that are seeing. And then traffic adaptive, which has been technically around since probably the 1980s, so definitely not a new technology by any means. And then some of the things that we've been kind of doing as a country, lots of agencies have been updating the traffic signal equipment, getting communication to traffic signals, adding detection so that traffic signals aren't pre-timed, um, and things like that, just to make traffic signal operations better. And what I'm going to be talking about is kind of incorporating a lot of those ITS investments into the signal optimization project. And all of this kind of is leading to the concept of active management of traffic signals, which is a newer type of philosophy that FHWA has started to promote with the active management cycle guide, which is a very cool document on incorporating active traffic management, being more proactive, reactive, and also being able to staff and ensure we have the workforce for that type. So the Minnesota DOT pilot consisted of 16 intersections spread across the South Minneapolis metropolitan area. Um, where what I'll be talking about combines what I call old school and new school type of traffic signal optimization. But the biggest thing that I'll be talking about is number one, a lot of the old traffic signal optimization process is still very good. So we're not taking any of that away. We're just building upon it. And I'll go through that once I go through the traffic signal optimization process. What's the traditional way of doing it? And then what's kind of the new adding big data, adding data analytics, and what's the impact of adding that as well. Um, we also wanted to add traffic responsive capabilities to at least one of the corridors. And also a big component of this was to train Minnesota Department of Transportation staff on the use of big data, how it can help, how it's really meant to make things easier, not harder, but it kind of really takes a big hump in order, you have to get over that big hump in order to get to that, because utilization of big data is a very scary thing. When we're talking about high resolution data enumerations, it's 200,000 data points that we're trying to visualize and help to improve traffic signal operations. And then also, if you're curious, MnDOT also has a pretty comprehensive report that I created that goes through the process as well. So what are ATSPMs? They're basically a way to visualize how our traffic signals are operating. So I'm going to be dividing it up into two different buckets. What I call the more traditional ATSPMs, which is using the high resolution data enumerations from the traffic signal controllers. So that requires a modern traffic signal controller requires detection. It requires a detection philosophy in order to get all the metrics. Usually you need stop bar detection, advanced detection on the main line. If you're talking about turn movement counts, maybe a really small pulse detector past the stop bar. So that's one is very infrastructure heavy. And then there's this newer component of probe-based data. So taking the connected vehicle um, data points, or in some cases, location-based services. But I'll get into that a little bit later, talking about the good and the bad of the location-based services, which is the GPS pinging of your cell phone. So all this information that we're getting, then we can generate certain performance measures, queue length, split failures, control delay, things like that, that can really help drive monitoring our signal operations and even drive how we optimize our traffic signals. One of the kind of big caveats between using the two together is the infrastructure-based SPMs are phase-based, but the pro-based SPMs are movement-based because they're not actually getting the signal statuses from the traffic signal controllers. So one of the challenges in integrating both of them together is converting one to the other. And in most cases, it is better to convert the pro-based movement data into phase data. So the ATSPMs that we use for the project, we use Flow Labs, which is our pro-based, and then we use the Q-free kinetics for the high resolution data enumerations, and both like great platforms to use, and both had their positives and negatives to using. And it's kind of just inherently nature to probe data versus getting point data from the traffic signal detection. For start with Flow Labs, and then I'll get to the Q-free kinetic system. So the biggest thing with this one is obviously the no infrastructure needed. One of the primary data sources for Flow Labs is the TomTom data. It's using the navigation systems that are in vehicles. Kind of what an analogy that I use to kind of describe why TomTom has better penetration rates is the NVIDIA chip. Lots of people know NVIDIA. Their chips are in a lot of different electronic devices, but you don't necessarily always know that it's an NVIDIA chip in the device. With navigation systems that are built into vehicles, it may have a TomTom core to it, but you may not know that it's TomTom. And it also incorporates the old school navigation where you put like those little devices, put them on the dash or something like that, and you got your put in your address and you get the location and it gives you directions and everything like that. So it can take from either one of those. And obviously not all vehicles have navigation systems built in. So we're obviously not getting 100% like we would get potentially with the high resolution data enumerations. It was flexible, so we were able to get a 6-month prescription, which kind of really made it beneficial for a signal optimization project, which isn't necessarily a long-term project. And it offers some really good metrics, corridor level, intersection level, movement level, turn movement counts, which I'll kind of get to a little bit later, and then like control delay, getting the speed. I'll talk about how that can be important when we're doing calibration of synchro modeling, getting where those split failures are, where the queue lengths are. Could be a potential different way of calculating the 95th percentile queue lengths. and also just the more traditional like arrival on green type of performance measures. So why did we select flow labs? For me, I had familiarity with it. I have ongoing projects in Washington or Wisconsin, Washington, D.C., and Virginia, where using the flow labs performance metrics and signal optimization. We have the ability to use the turning movement counts, which really gives us an opportunity to switch the costs. Typically, we send people out there to do the turning movement counts. If we don't have to do that, then we could take that cost that we would have sent there and utilize and buy the probe-based data. And there were some metrics that are kind of very unique, at least today, with the full S platform, like the ability to get queue length, speed, stops, and fuel and emissions. It might be that in a couple months, other pro-based platforms have that type of thing. It's a very ever-changing world. And then the higher penetration rates was very key for us. Typical is about 25 to 40%. And the example of one I'm in the process of finalizing a pro-based SPM study for Washington, D.C., where we looked at multiple different vendors and we were able to see the penetration rate of each of the vendors. And what we found is the penetration rate was very close to what the vendor was saying. In the case of DC, it was actually on the higher end of that spectrum as well. And we saw a very good correlation. You can kind of see in the chart here, as the volumes were increasing, we're actually getting quite a lot more pro-based vehicles, which was also a really good sign. And then the turning movement counts. Biggest question I always get is, are they accurate? And for this type of scenario of doing signal optimization, we're in the good enough realm of factor. So we did once again, big study where we looked at 5 intersections, 24 hours in Washington, D.C., and we actually did the statistical testing. We looked at the estimate and we looked at standard deviation. For all the statistics people, the estimate is kind of just getting the how accurate are we? And then standard deviation is how close are we to the mean and everything like that. How are we predicting the vehicles or forecasting? So we found that the lower numbers, we did have worse accuracy, but that's what it really pairs with the standard deviation, because technically we were less accurate, but we also have to look at the numbers of what they are too. So if we have a count of 1 and we predicted a count of 2, that's technically 100% off, even though the numbers are very low. If we have the high numbers, if we're going from 30 to 40, technically I'm off by more vehicles, but the estimate value is a lot better. So that's where standard deviation really came into play. While the lower numbers were technically less accurate from a statistical standpoint, the standard deviation was actually very low for those. So if the volume coming in is 2, we're not predicting 30. We're still in that realm of, we're predicting maybe 4 or 5. So we're still in that realm of very accurate. So once we kind of analyze this between low volumes, high volumes, both estimate and standard deviation, it was very promising results. And when we average longer periods of time over the month, it gets even better, which is one of the decisions why for the Minnesota DOT project, we didn't just take one day. we took an average span over a 1 month period. Quick question that I might get is why did we use SMAPE versus MAPE? And that's to solve the divide by zero problem. With MAPE, obviously you can't divide by zero, so then it requires the removal of some of the data points. SMAPE allows for essentially a ground truth volume of zero. And for the Minnesota DOT project, basically just spot checking using the CCTV camera, getting some really quick volumes and ensuring that they're accurate. And we did a little bit of a calibration for the MNDOT project. And as you can see between these two values, one's before calibration, one's after calibration for the DC project. After we calibrate it, the volume or the predictions are even quite a bit better. So then the next question is, what about the multimodal considerations? This is kind of where I get into my little talking points about the location-based services or the pinging of the cell phones. One of the problems with using cell phones is really in congested areas. If the vehicles and the pedestrians and bicyclists are pretty much going the same speed, it's very hard to differentiate between the two or the three. And also with cell phones, what happens if you have 5 people that all have cell phones in one car? Technically, that should get filtered out because it's only representing one vehicle, and then that can create a data bias. And then there's also some issues with, like, what if there's tall buildings? There could be stress on the cellular bandwidth, which can impact getting the GPS coordinates. I know when I'm in downtown Chicago, sometimes it puts me correctly, and sometimes it puts me like a half a block away. And then second later, it puts me back and things like that. And then also, is the cell phone in your pocket versus in your hand? All that stuff matters with getting those GPS coordinates. And there are some apps that do have that where you can like track your bicycle workout or track your pedestrian steps. One of the ones that kind of comes to mind is Strava Metro. And those are actually very good, but people tend to not use them, so we don't really have a good sample size of them. And so the kind of conclusion, just for signal optimization perspective, is relying on the other data source that we have, which was the high resolution data enumerations. How many times are people pushing the push button and getting served? The actual pedestrian volumes themselves are kind of more geared towards the planning phase, the planning people. From a traffic signal perspective, we just need to know how many times is that ped getting served, and do we potentially have too many peds? Do we have to accommodate the full ped and split, and things like that? So then this is the second data source, the kinetics, which is that very traditional open sourced ATSPMs that Utah DOT created and was part of the Everyday Counts 4 initiative. One of the great things is it's included in the ATMS. So it's just a matter of configuring the detection and everything like that. And we get our very traditional ATSPM metrics that most people know, like the split monitor, the Purdue phase termination, Purdue coordination diagram, which are very important when we're considering traffic signal optimization and the different scenarios that we're creating. And I think this was the kind of little breaking point on if we had any questions. We could potentially answer them before we go into the actual optimization process.
Justin, you must be doing a great job. I don't see any questions in the chat box so far. You might check yours to see if anybody's directed something exclusively to you, but in terms of what I see, we're good. We're clear to move on.
Good. Keep going. So now we go into the signal optimization process, traditional to the left and the objective and performance-based process to the right. So typically what we do is we get like a trigger. It could be we got a complaint from a citizen, we get a new development. It could be the life cycle if we're retiming every 3 to 5 years. Then that kind of kicks off a project where we go to the design, we collect data, we create simulation models, optimize, implement, calibrate, evaluate, and then kind of be done with the corridor until we start the process again. And then the goals and performance-based process is gearing more towards goals and objectives. The goals are typically the goals of like the broader goals of the agency. And then the objectives are more geared towards, in our case, traffic signal optimization. Traffic signals, there is what I call four main objectives of smooth flow, throughput, access equity, and queue management. All four of these objectives are in conflict with each other. So it's not we want all the objectives. It's more, here's 100 tokens. How would you distribute your 100 tokens between each of the objectives for different peak periods, different time of day, and things like that? And then this process really incorporates the performance measure loop. It really uses those performance measures to see, are we accomplishing our objective? And our objective might be to increase delay in order to really help out multimodal type of considerations. We don't want any PED to be oversized or anything like that. We want to accommodate everything into our split times, and that might drive up cycle length and add more delay. So really keying in on those performance measures to ensure that we're achieving our objective. And if our performance measures aren't exactly what we want, then we understand why. And then maybe we want to change our objective and then kind of keep going through that process and fine tuning, which then kind of gets us a little bit into the realm of active management of traffic signals, where we're essentially not doing the process to the left, and we're just more doing maintenance in a proactive way. So I'm going to go through my typical 6-step process for traffic signal optimization. I'm going to go through each step and kind of what's the traditional way and what's the different way that we're doing. First one being data collection. Typically get like 13-hour count or maybe AM, mid, and PM counts. With the new way of doing it, it's more long-term type data. We have data over weeks, months. We can aggregate lots of data together. We can filter out data. If we see that certain days have anomalies, we can really filter that data out. So some kind of takeaways from the MNDOT project is it was important to get a format. We didn't just want to take the export from the flow lab system. We wanted to convert it into that typical turning movement count format where we can get the AM, mid, PM automatically generated. What's the AM peak hour? What's the PM peak hour? Make sure that we're getting the peak hour factor and all of the items that we're typically seeing when we have a turning movement count. And also, this was kind of the step of programming the detection in the kinetics platform, which MnDOT has decided that they're going to lean more towards a consultant-led process. As we're going through signal optimization of their corridors through um, their process every 3 to 5 years at each corridor, it's adding the detection into the Kinetics platform so that it doesn't just become a big burden on the agency itself. When the project is done, the agency can kind of have confidence that all the ATSPMs, all the detection in kinetics is programmed correctly so that they can get ATSPMs long term. And then the field review, typically done in person, which can be inefficient. Um, you always factor in like the consultant or the agency personnel. They gotta get in their car, they gotta drive there, especially if it's a state DOT. It could actually be a good distance to get to the outlying intersections and things like that, which is time is money. Um, so this is getting more into a remote type of way of doing it, where we have quite a lot of different platforms. We got CCTV cameras, we got the flow labs, we got status display from the Kinetics platform, and stuff like that. So it really makes the time efficient that we can be watching the intersection, and also we can be watching multiple intersections at the same time, just with a really large screen and things like that. We don't have to drive to one intersection, stop, watch, drive to another intersection, stop, watch. We're getting a more holistic view of the corridor itself. And some key takeaways. Longer duration timeframes were used. So instead of that 1 to 2 days, using quite a lot, we used cluster analysis, which is an traffic analysis toolbox, volume 3, from FHWA. Kind of just like it's a broad introduction. We took that and kind of geared it more towards traffic signals. Cluster analysis is, think of like plotting volume against time. If it's two-dimensional, chances are you can kind of take and circle your groups of data points. The problem really lies in um, how do we do multiple different dimensions? So I want to do time against 8 different performance measures. That's something that we can't just see just because it's multi-dimension. So that's where the mathematical equations type come into play. Also, we were creating heat maps so that we could visually see the data where certain things were grouped together. Is our AM peak and our PM peak having the same problems? Are they having different problems? Is our mid peak having any problems? How is that compared to our AM and PM peak and things like that? So we did that on a corridor level, an intersection level, and then down here is our movement type level, which is the really fine-grained analysis. And we also did the trend analysis. So the chart here is showing the traffic volumes along the corridor for span of 3 months. And Minnesota, they got winter, they got snow, so they were kind of in that downward winter trend. But then once April kicked in, they got into that upward trend. We're getting closer to summer, we're getting more traffic out there and things like that. People are going on spring break and all that. And the low point here, I wanted that point to stay in just to kind of prove a point. This is a holiday. The bottom one is not zero, so it's not saying that we're getting close to zero, but it is showing the dramatic decrease in volume that a holiday could have on the data as well, which definitely needs to be filtered out when we're doing these types of analysis. The modeling and simulation, a lot of things kind of perpetuate from that step one. Um, So coding very limited data set, versus now we're kind of coding in a lot of data. We got the pedestrian data from kinetics, we got flow labs data, we got potential calibration that we can do to the modeling itself as well. So being able to kind of take split failures and control delay, and then seeing how our simulation model is actually faring, given um, what we actually know in the field now. And how we calibrate synchro is really um, independent of the traffic signal engineer. There's different ways to calibrate based on different metrics. Um, and another one that I wanted to talk about is getting the speed, the approaching speed. That can kind of make or break our offsets. We have some cases in Washington, D.C., where we have a bus that pulls off away from traffic. So it's actually not in the travel lane, but it has a big impact on the vehicles that are going through. So we kind of call that speed friction. And if that's not modeled correctly in synchro, that can make or break an offset at the next traffic signal where people are arriving basically when the traffic signal turns red instead of when the traffic signal turns green, just because they're going at a lower speed. They're they're a little too close to that bus, so they have a tendency to really slow down. And the buses are every 4 to 6 minutes, so we're talking every 2 to 3 cycles. So it really can be impactful when things like that happen, and need to be ensured that they're in the model correctly. And then the optimization. I think a lot of optimization programs kind of get a bad rap, but a lot of that has to do with the data that goes into the model. We could have the best simulation algorithms in the world, the best optimization algorithms in the world. But if we have garbage inputs, that will always give us garbage outputs. So ensuring that our optimization kind of really incorporates the better data set can really make a huge difference and turn hitting the optimize button in synchro, which I'm not saying to do, but it could mean having a good result over a bad result. But in our case, it's more what I call the art of traffic signal optimization. It's using all the data sources. It's telling us, when is simulation wrong? When do I not need to listen? When do I know vehicles are arriving? And kind of tweaking our time-space diagrams so that we can accommodate that. And also keeping the old school methods, the 4+2n rule for split times and things like that, making sure we have variability when we need it, when the data shows that our split time, if we have it really capped off, it's really going to be impactful. If we have just a little bit over, all of a sudden we're having a lot of split failures for that phase. Maybe it's better off that we increase that split time to just make sure that we accommodate it more often. Um, Kind of some of the other takeaways is I think I pretty much covered a lot of this stuff. One of the big things that we had was one of the interchanges was having a lot of extra traffic due to reconstruction on Interstate 494. So traffic was bailing off and taking a different route to get to basically beyond the construction. Um, so we had traffic volumes from September, but we were implementing in, I believe, May, September 2024, and then implementing in May 2025. There was actually a pretty big difference between those two volumes, as I'm kind of showing here, where the AM peak was actually significantly lower, and the PM peak was a little bit higher, which led to a very sudden change in the cycle length that we picked. We were able to make a really quick pivot, and instead of a 110-second cycle implementing, we ended up implementing a 100-second cycle. And the 100-second cycle actually worked very well with the changing volumes. So sometimes we take our train movement counts and then it's a process, and then we implement a couple months later. This can actually catch some of those types of errors before they're implemented. And cycle length is probably one of the hardest things to change in the field because it impacts every single intersection. And then also we were able to create better time of day schedules. So we were really able to line up all of our coordinated plans and ensure that when we're implementing them, it actually matches the traffic volumes that we're optimizing. And when we're changing, we know exactly when we need to change. And then because we're getting that 24/7 counts, we can make sure that we get it right on the weekends as well, and kind of see which pattern does it mirror better. Typically, we just put the mid peak on the weekends, but we actually found in this case that in some cases we wanted like a PM off peak or an AM off peak, just because that's when there was a lot of when traffic was increased, it just matched those traffic patterns a lot better. So we're able to get some reductions on the weekends as well. This one's the easy one. Implementation, infield or remote. In this case, it was done all remotely. May not be the case in every single scenario. I have another project with MNDOT where one of the corridors we're still going to implement in person next year. So, and then we also implemented traffic responsive at that interchange that had the more variable traffic due to the diversion traffic. So, and Kinetics was a great platform to code in the traffic response. So very intuitive. And I really liked how it was designed and how I could implement, see the changes, and kind of correlate it a little bit to the ATSPMs as well. And then the field calibration, kind of similar as the field review, can be done very remotely, very similar types of benefits. It was cut short with this project. One of the lessons learned with Flow Labs was the ability to take past data. So our schedule for our next project is accelerated a lot so that we can really incorporate this process. But this is also where I kind of wanted to show that the heat maps that we created, essentially what we did was we created a little document from MNDOT that kind of correlated, like, here's a heat map, but then here's what the heat map says. And this is what we were looking at when we did the signal optimization. Some kind of those key areas of improvement that we were seeing that we could do. And a lot of these corridors were very, other than the interchange that was getting diversion, were very uncongested corridors. So chances are you're not going to get a whole lot of bang for your buck. So we were, by using the data, we were kind of able to really squeeze more benefits out of it that we may not have been able to squeeze out before. Which is a good segue into my benefits. We did a benefit calculation for each of the corridors, each of the intersections, delays, stops, fuel consumption. You can see that the interchange with the diversion, very skewed. Had a lot of benefit to it, which the data that we were seeing even showed a phasing change, which was very helpful in getting a lot of that reduction that we were seeing, to the point where you can see here's the before condition where you can clearly see that traffic is backed up onto the freeway. But in the after condition, much, much better. So very good scenario. Developed into a 29-to-1 benefit to cost ratio, which was very good for this type of scenario. Very good delay, fuel, and emission savings. And the kind of cool thing is this includes, because we didn't do the turn movement counts, the flow labs was included as part of the consultant services. So it was just a direct cost. It was part of the project. So the benefit to cost ratio actually factors in the cost of the flow lab system. It does not include the cost of kinetics because that was just embedded in regular MNDOT processes. Either way, they were going to have a central signal system. Some kind of concluding lessons learned. We thought that the 6-month subscription was sufficient for the project. Kind of have 2 months of past data, and then the rest of the months is more geared towards the implementation, getting before after metrics, and then using it for calibration as well. MnDOT has a flashing yellow arrow spreadsheet. Sometimes they determine the need to have their left turns protected only versus protected permitted versus permitted only. One of the added values of using the Flow Labs data was we were able to incorporate the full 24 hours, but then something that they typically don't have is the weekend data. So we're able to do um, the worksheets for the weekend volumes as well to just double check, see if we're missing anything and things like that. It was very it was not time consuming to implement the detection. So moving forward to have the consultant do it is very minimal add-on cost for the project. Um, that historical, using those months in the past, can really speed up a project. And then the big thing is longer time frames and more in-depth analysis. This is kind of my overarching, that's my last slide, of accountability. We know what we're implementing. We should know all the benefits we're getting. We really defined our objectives, things like that, getting that increased value, getting that increased quality, longer durations, that customized approach. We're looking at each intersection, each corridor individually. We're really fine tuning on specific movements and things like that. All things that are very easily seen with the big data that we have. And then kind of getting into that active traffic management, which is something that's important to me just because, not only because it's my FHWA project, but it's just something that we see the industry moving towards, which is really cool. So with that, I think we can switch over to the Q&A.
All right, yes, we have some questions here in the chat box. So I'll read these in order, read one at a time, let you respond. And our first question is from Kwaku. His question is, in your field observations, were there instances where the queue spilled back from one intersection to the other? And how did you handle the optimization in this scenario?
Yes, we had one, and that was the interchange that was handling the diversion traffic because of the I-494 construction. And it really showed in the data analytics that we were doing, the cluster analysis. We were seeing kind of some things in the data that we were like, oh, I bet this is oversaturation. Vehicles are extending on, potentially even blocking other vehicles because they get frustrated and they They just want to get in the area so that they can go whether they're blocking other vehicles or not. And we handled this by essentially changing the phasing of the both ramps themselves. They're not controlled by one controller, they're controlled separately. Um, and we created two different scenarios. One was a scenario where we allow vehicles to kind of stack in between, and another vehicle or another avenue where we did more of the TTI type phasing where we have zero vehicles stacked in. And we found that we didn't have to go to the second option because the new phasing we had really cleared out that traffic in the AM peak, that traffic coming from the RAM. So that the problem before is they would just get stuck and then it would just queue back and then queue back. By really filtering that out, and the negative to that was the eastbound traffic then came to a stop at the ramp. So we also wanted to make sure that the eastbound traffic did not queue to cause a problem at the other ramp where we're getting blocked vehicles and unsafe type situations. The data showed that it would not happen. And then once we implemented, it also did not happen. So but we had that backup timing where we could max out certain phases so that we would just basically take away the potential safety problem. But it was kind of a neat situation where the data really helped us a lot in determining how did we want to make those phasing changes with the left turns leading versus lagging and things like that. So it's kind of a neat exercise.
All right, next question comes from Marcelo. It is, when an intersection involves interstate off-ramps, how do you decide on the priority and allocate green time, especially if the major road is operating at or near saturation?
That's a good question. And it's really dependent on the situation itself. We have safety considerations that we need to factor in on both worlds. We definitely want to make sure that we're not stacking vehicles so that we're blocking the ramp or anything like that. So that becomes important. But we also need to factor in the ramp of if we have a high-speed freeway and vehicles are queuing up, that speed differential can really create bad scenarios on the freeway itself. So it's a matter of balancing the two and being very creative in the way that you're doing it. So I'm sorry that I don't have like a very specific answer because I would say it depends on what the data is showing and um, what the scenario is. There's a lot of advanced functionality in modern traffic signal controllers where we could potentially add in some advanced logic so that we could potentially flush any type of direction based on certain conditions that we're seeing. And for me, it would be what does the data show and where do we need to put the priority? It's not as simple as we put the priority on the ramp. I know that's kind of the traditional way just because of the potential safety issue with the freeway. But there's quite a lot of different scenarios that we could factor in. It could just be that we get a little sun surge out in the off ramp. We need to accommodate that real quick. And then we're going to put the bulk of the priority on the main line. So it's the priorities on the main line, except this isolated case on the ramp that happens every day from 7:50 to 7:55 or something like that. Um, so there's a lot of kind of neat things that we can potentially do with detection and things like that to mitigate so that we're not just prioritizing one at the expense of the other. Hopefully that makes sense.
Yeah. Okay, next question comes from Faraz. Question is, does the calibration of a specific intersection affect downstream traffic, and how does it handle the change?
It's a very good question, and that's where we really have to factor in kind of all of our friction that we could potentially have between intersections. I know when we were doing one of the corridors, it's two RAM signals and then a county signal, and they're all in the same system. And one of the things that the data was showing was there was a huge volume from the southbound off ramp, and all that traffic, probably a quarter of it was turning left to go north at the county intersection, but the bulk of the traffic was going through the intersection. But changing that traffic signal to really be a priority with that southbound off ramp, it did have its complexities because we had to really hone in what's the speed of those vehicles as they're making that turn and what's their acceleration as they go through the other ramp signal. Really honing in on that was beneficial and an impact at the next traffic signal. So a lot of that stuff is kind of very individualized, but it's pretty easy when we're talking big data platforms because we're not talking about taking raw data and analyzing it. We're talking about, oh, it's 3 clicks away of finding out what that potential speed is so that I can maybe tweak my offset so that I can accommodate a little more volume off the ramp, but so that they still can progress through the other ramp on a green. And also, we can use that as a way of um, speed management as well. One of the caveats to completely catering to the data is also being aware of speed limits that we have and ensuring that we're not creating situations that promote speeding along the roadways as well.
Okay, next question comes from Darren. It is, how did you calculate costs due to delay? Was it lost time times the average wage?
It was based on it is based on time. So it's basically what's the total delay in the existing condition, what's the total delay in the um, after implementation conditions. That'll give you a delta hours, and then in our case, Minnesota had already done a study on what the value of time is. So we use their value, and then when we're talking about what's the value of less stops, we switch more to the national standards. So I have documents and specific tables and stuff that I reference when doing those calculations. I reference all that in the report.
A last question in the queue comes from Jake. His question is, can the system adapt automatically to irregular traffic scenarios such as sporting events or concerts, holidays, road closures and detours, or similar events?
We're not necessarily talking about like an adaptive type system. We can create scenarios where the traffic responsive system would work better in different types of events, which would be helpful that someone doesn't actually have to implement them. But where this process kind of really gets better is taking the data from those events and determining, do we need a brand new signal timing for that? And can we implement a new coordinated plan potentially next year with the same type of event? or clustering certain events and things like that. And that's kind of how it gets into more of the active traffic signal management where we have something, we just need to tweak. We don't necessarily need like a brand new, full blown signal optimization. We know our corridor really well. We created this based on past data. Data is a little bit different, this one, because maybe it's a state fair event, it's raining, something like that, we get less attendance. We're just tweaking it. We're not kind of creating something brand new. But from a traffic responsive perspective, having the data can really help us to automate the process a little bit more, which really helped with the MnDOT project because the diverting traffic was very different on a day-to-day basis. It was more prominent Tuesday through Thursday, but then there were cases when it was a holiday and freeway was perfect. And in those types of cases, it never went into the AM or PM peak timing plans. It stayed at the nice low cycle length.
Okay, our last item in the chat box at this point is a comment from John, and I believe this goes back to the first question about, second question about looking at setting priorities where you have signalized intersections serving freeway off ramps, and John pointed out that it could often be a policy issue depending on the state or other authority, in charge of the situation where you may not necessarily have discretion to decide how traffic is prioritized. For instance, the clearing freeway ramp may be the top priority.
Exactly. It all goes back to the goals of the agency.
Okay, that's got us to the end of the queue in the chat box, and we are at 12:02. So I think timing worked out very well there. I want to thank everybody again for joining us. Justin, I want to thank you for taking the time to join us and share your experiences here on these projects with us today. Appreciate that very much.
Thank you.
So, keep an eye on the chat box to make sure nobody sneaks in a last second question here. But I think, barring that, I think we've wrapped everything up. As I said, if you signed in when you joined us, no need to sign out. If you did not sign in as you came in, you might just enter your first name and last name for us. That'll help us make sure we pair everybody up with their Zoom user ID and make sure you get credit for viewing so that when we send out the PDH certificates, you receive yours. All right. Well, with that, I'll leave the session open for just a little bit longer in case we have any last minute questions or requests for follow-up information. Thank you again, everybody, for taking an hour out of your Monday morning to join us, and hope we'll see you again soon. All right, Justin, I don't see anything new in the chat box, so I am going to go ahead and end the session. If you need anything in follow-up from Ayrton or I, please let us know. We'll be glad to help you out with anything we can.
Thank you so much.
All right, thanks again. Hope you have a great day.
You too. Bye.
Bye.